Now, good morning, ladies and gentlemen. My name is Mr. B.N. Mupeti, and I want to take you through physics. So this is just a summary. Okay, so basically you guys need to know that you use certain instruments to measure certain quantities. Now, the first thing that you need to know is that you use rules or meter rules to measure length, and you use stopwatches to measure time. You use beam balances to measure mass. Okay, so these are things that you need to know, and basically there are ways of correctly positioning your eye when you are taking measurements. Now, for example, this is wrong. Okay, so you are checking from an angle, so you'll have something called parallax error taking place there, and then this way again you're also checking from an angle, so this is wrong. There'll be parallax error. Now this is correct. Okay, this is the correct position of the eye when taking a measurement. So you're measuring the length of this side here. Okay, and can you see that it's starting off at 0 and then it's ending somewhere there, and then this thing is in contact with the ruler. Okay, there is no space, so it's actually wrong to leave a gap like this way or to leave a gap like this way. Okay, because here you end up measuring a much more greater value than the actual value. Okay, so these are standard practices which we need to know. And we also need to know some terminology like precision. What is precision? What is accuracy? Now, precision is how close the measured values are to each other. So if you've got wrong values, but they are very close to each other, then you are precise, but you are inaccurate. Okay. Now, accuracy is how close a reading is to the true value of the measurement. Right, so now let's take a look at volume readings as well. When we are taking volume readings, we also use the same approach. So basically your eye is to be level with the bottom of the meniscus. Now the bottom of the meniscus is this curve that goes downwards. So don't take the measurements here at the ends, okay? These measurements are quite higher, okay, than the bottom of the meniscus. Take the measurement, the lowest measurement, the bottom of the meniscus, and your eye needs to be in line with the reading that you're taking. Now, some other precautions which you need to take. If you want to measure the volume of the liquid inside a measuring cylinder, you need to place the measuring cylinder on a flat surface. Now, if you carry it in your hands, you might slightly slant the measuring cylinder and you end up getting a much greater reading than you're supposed to. Okay, so we also use the same approach when taking a reading from a burette. Now, with regards to volume, you should know that the instruments which we particularly use, instruments which are accurate enough to give us reliable values of volume, are the measuring cylinder, the burette, and a pipette. Now, a pipette can only give you one particular measurement. That is the measurement which is indicated on the bulb. For example, most pipettes are meant to accurately measure 25 cubic centimeters. So you need to know this, okay? But a burette and a measuring cylinder, you can measure quite a range of volumes. Now, the other thing that you need to know is that if you are measuring a small volume, let's say 5 cubic centimeters or 7 cubic centimeters, you are better off using a smaller measuring cylinder, like a 10 cubic centimeter measuring cylinder to measure 7 cubic centimeters. Don't use a 25 cubic centimeter measuring cylinder because it will be much harder to go through those graduations. It's got smaller graduations, it's less accurate. Okay, for example, take a look at this burette. It's meant to measure 50 cubic centimeters, and this measuring cylinder is meant to measure less. So can you see that there's a lot of spacing between the graduations? It means that even if you pour some liquid in there, it's very easy to get accurate results. Okay, so this is stuff that we need to know. Right, another thing that you guys are supposed to know is that clocks and stopwatches are used to measure time. Okay, and then these stopwatches and clocks are prone to errors due to your reaction time. So sometimes it takes a long time for you to start and to stop a stopwatch. Imagine you are supposed to record the time for an athlete who's running in a 100-meter race, and then you start your stopwatch slightly slowly, and then you stop it slightly early. So you're going to get a wrong time. Okay, so basically these kinds of errors are referred to as reaction time errors. These are sources of errors, and during your alternative to practicals, you'll be required to explain how a particular method can be subjected to errors. Now, there's also one other thing that we need to know when we're taking some time measurements. For example, when we want to see the period of a pendulum. Okay, now the period of a pendulum is when a pendulum makes one complete cycle. Okay, so apparently the time that you get from one complete cycle might be too small, so you might need to leave your pendulum to do about 50 cycles, and then you divide the time that you get by 50. So you are likely to get a much more accurate reading if you do that. Okay, so to accurately measure the period of a pendulum, you must time a large number of cycles and calculate the average. So this is an approach again that we use in science, and you need to be aware of this approach. Right, we also have a topic called motion. Now, with regards to motion, you guys are expected to be able to calculate speed. And, speed is not hard to calculate. You've done this in Form 1, Form 2, Form 3. Now, speed is equal to total distance over total time. Actually, average speed is equal to total distance over total time. Okay, now it's important to highlight that this time includes the stoppage time. Let's say you're going from Bulawayo to Harare. If you decide to stop in Gweru for 5 hours, right, we're going to include that time in the total time. Okay, are we together? So it's including the time when you're moving very quickly, the time when you are stationary, the time when you're moving very slowly, right? All that time is included. And then the total distance, we're looking at the total distance from Bulawayo to Gweru. So average speed is total distance over total time. Now, because this is average speed, it doesn't mean that this is the speed that you travel at throughout your journey. At some points you might travel at a much higher speed, at some points you might travel at a lower speed. But basically, if we sum up the total distance that you've traveled and the total time that you've taken to travel that distance, including the time when you stop and you relieve yourself, when you stop at a filling station and you fill up fuel, when you stop and you go into a supermarket to buy food, then we're going to get average speed. Okay, right. Now, you guys are also expected to be able to deduce information that you get from distance time graphs and velocity time graphs. Now, distance time graphs and velocity time graphs are very different. You can see that these two graphs look the same, but what makes them different is what's there on the y-axis, okay? Right. Here on the y-axis, we've got distance in meters. Here we've got velocity in meters per second, or speed in meters per second, right? Their x-axis are the same. They both have time. Now, let's take a look at a distance time graph. This one here, which is on the left. Now, a distance time graph, if you get a line like this blue line, or a line like this red line, then that means that you've got constant speed. We also refer to constant speed as steady speed. So that means that you are moving at a constant speed. And now here, since this is distance, if you have a line like this here, which is parallel to your x-axis, then that means that that object is stationary. If it is a car, it means that that car is stationary. Okay, if it's a train, it means that train is stationary. So this only applies to distance time graphs. Okay, if you have a line like this, it means that the object is stationary. It means that you have stopped somewhere. Maybe you've stopped at a supermarket. Your car is no longer in motion. Okay, now when you get a line like this here, this is also steady speed, but it's now returning back. It's now returning back from where you're coming from. Okay, it's going back from where you are coming from. That's why you see that the distance is decreasing up until 0. When you arrive back at your home, okay, you've returned back to where you came from, so the distance covered is now 0. It's like going to Harare from Bulawayo and going back to Bulawayo. So you're now back home, isn't it? So the distance is now 0. Right, so a line going up, it shows constant speed. A line going down also shows constant speed, but this one shows constant speed returning to the start. Okay, now let's take a look at a speed time graph, or a velocity time graph, as you may call it. Now, basically, if you've got a line like this here, this shows constant acceleration. It's different from a distance time graph where that line shows constant speed. So you should know that in this case, that line is constant speed, and then in this case, it's constant acceleration. And then here now, because this is velocity, this is speed, this shows constant speed. This is the same as this line here and this line here. Okay, right. And then when it's going down like this here, it shows constant deceleration. So going up is constant acceleration, going down is constant deceleration, and when it's a straight line like this, it's constant speed. So these are things that you need to know. Right, another thing that you guys also need to know is that the area, okay, under a speed time graph gives you total distance. Okay, so let's take a look at the total distance covered, right? In this graph here, we're going from a time of 0 to 4. So what is the total distance covered in 4 seconds? Remember, this is time in seconds. Now, in 4 seconds, the total distance covered is the area under this triangle over here. Now, you know that for the area of a triangle, you need to know its base and its height, and you need to divide the product of the base and height by 2. Okay, so let's take a look at the base here. What is the base? The base is 4 and the height is 8. Okay, the base is 4 and the height is 8. So for like in 4 seconds, the total distance covered will be half 4 times 8, which gives us 16 meters. Okay, right. Now, basically, why are we saying that the units are meters? Because the speed is in meters per second and the time is in seconds. So speed is meters per second and time is seconds. So the distance will be in meters. Okay, right. What about for this dark area here, this gray area? For between 3 and 4 seconds, what distance is covered? Now, you can think of this as a very complicated example, but no, it's not. We need to actually come and divide that. Let me just get a color here. Okay, so basically you can see that if we draw a line here, we're going to have a triangle. Sorry, my triangle is not very straight. Okay, and then we've got A there, and then we've got B here. Okay, right, as you can see right there. So we now have a triangle. Right, now basically we can calculate the area of this triangle at the top, and then we calculate the area of the rectangle down there. Do I need to redraw it again? Okay, let me just redraw it again so that you guys will be able to follow. Okay, so I'm drawing this triangle here, then I'll call that A, right? And then this rectangle here will be called B. Okay, so the area covered in between 3 and 4 there, right, in this 1 second here, okay, this time interval, the area is this one here, the area under the graph. So we've got a triangle there, and for a triangle, look at this triangle here, its base is 1 and its height is 2, because we're going from 6 to 8, so that's 2. So this is half 1 times 2, and then for this rectangle here, we have 1 for the length, and we've got from 0 to 6, we've got 6 there. So it's 1 times 6. Okay, so now the total area under this part here, okay, is equal to 1 plus 6, which is 7. Okay, so that's the distance traveled from a time of 2 to a time of 4. Okay, and that's the area of the shaded region, this shaded region right here. So this is stuff that you guys need to know. You need to know that a speed time graph, right, you can get distance traveled by looking at the area under the graph. Okay, and you need to know that if it's a triangle there, then you're going to use half base times height. If it's a rectangle, then you're going to use length times width. Okay, right, so these are things that you need to know. Right, now the last thing that I want to look at is a summary of distance time graphs. So if you've got something like this here, it's showing you constant speed, okay? And then if you've got something like this here, the distance is not changing, it's not increasing, it's not decreasing. That means that the body or the object is at rest, okay? It's not moving. And then if you've got something like this here, this shows acceleration. It's a curve, an upward curve. It shows acceleration. So this here is constant speed. This is at rest or stationary. This is acceleration. Now, these ones, they show constant speed. A, B, and C show constant speed, but A is a higher speed because the graph there is much more steeper. Okay, it's much more steeper. So A is the steepest, therefore it has the higher average speed. Okay, it's constant speed, and then B is the second highest constant speed, and then C is the lowest constant speed. So this is where we leave it for today. Have a good day.